You are probably used to seeing functions that look like this. X is our variable. That means it's where we plug in different numbers. So you put in a 1 and get 1 squared, which is 1. And if you put in a negative 1, you get the same answer, since a negative times a negative is positive. You have also probably seen functions like this, where again, the numbers changing are the ones we are raising to the third power. That's the variable. So 2 cubed is 8. And if we plug in negative 2 instead, we get negative 8, because negative 2 times negative 2 times negative 2, that's negative 2 cubed, is negative 8. And we can keep doing this, changing x to any number we want. Now suppose instead of having the variable in the base like this, the exponent is the variable. That is the term that changes. Can you see the difference? This is called an exponential function. And this one specifically has base 3. What is so special about these functions that we tend to see them so much in math? Let's plug in some different numbers for x so that we can explore. Plugging in 1 for x, 3 to the 1 will just be 3. If we plug in 2 for the x, we get 3 to the second power, which is 9. Plug in 3 and we are at 3 cubed, which is 27. Now if we plug in 4, we are at 3 to the fourth, which is 81. We can see just going from plugging in 1 to 4, our answer has gone from 3 to 81, which is a pretty big jump. Let's take a look at the polynomial function to see the differences. If we plug in 1 for the variable into x cubed, we get 1 cubed, which is 1. Plugging in 2, we get 2 cubed, which is 8. Plugging in 3, we get 3 cubed, which is 27. Putting in 4, we get 4 cubed, which is 64. So we can see that the polynomial function, which is this one on the right, it doesn't grow as fast. You can test it by putting in even more values for x, like 5, 6, 10, and you will start to see a dramatic difference as the numbers you plug in get larger. Let's take a look at the graph of 3 to the x. Here is where x is 1, so 3 to the x is 3 to the 1, which is 3. Let's look at what happens when x is 2. We had 3 squared, which is 9. Then when x is 3, it shoots to 27. And when x is 4, the value is 81. So we can see that this exponential function just really takes off and grows fast. Let's compare that to the polynomial function, x to the third, or x cubed. We can see that x to the third is underneath the exponential function, so it's smaller and grows slower. But let's get a better look. Let's see what happens when our x gets bigger. Farther out to the right, because that is where you really see the difference. So here we are looking at the exponential function, 3 to the x. And here is the polynomial function, x to the third. You can see that compared to the exponential function, the polynomial one stays to the bottom a lot. It actually just looks like just a slightly curved line down there. It looks like this, like just a line that's slightly curved because we have it plotted with the exponential function, which comparatively is just so much higher. At x equals 5, we are at 243 for the exponential function, which was 3 to the x. And at x equals 5, we are at 125 for x to the third, the polynomial function. I know it looks like they have the same y values, but that's only because the graph is so zoomed out. And here at x equals 8, then x equals 10, we can see that they get further and further apart. Okay, so let's just look over what we have here. The orange graph is 3 raised to the x. So where the exponent is the variable, that's getting bigger. The blue graph is x to the third power. That's the polynomial one. So the base is the one that's changing. That's the variable. We see that they start off somewhat close together, but already when x is 8, they are much different. Follow the orange graph to the right, to the second orange plotted point. This point shows us when we plug in 8 for x, so we have 3 to the 8, we get 3 to the 8 is 6,561. Now let's follow the blue line to the second point. So whenever x is 8 in this one, in the polynomial one, we have 8 raised to the 3, which is 512. So we see that the orange plot is much bigger. Okay, then follow the orange plot to the next point. When x is 10, we are already at 59,049 for 3 to the x. The corresponding blue dot is if we plug in 10 into x cubed. So 10 to the third is 1,000. We can see this is an even larger difference and that the orange plot is just growing super fast. So the goal of this video was to give you an idea of what an exponential function is and why it is important. It is growing super fast, so it is used to describe things that grow really fast. It is different from the polynomial functions like x squared or x cubed because it grows much faster.